Okay, this is problem number 7 from section 1-2. This is a word problem. It says an open box is to be constructed from a square piece of sheet metal by removing a square of side 4 feet from each corner and turning up the edges. If the box is to hold 484 cubic feet, that means the volume has to equal 484. What should be the dimensions of the sheet metal? Okay, that would be the big blue box, those dimensions. The little boxes that we cut out right here, it tells you that each one of those is 4 by 4. So that's what that is. And we're talking volume here. So we drew this picture to represent it. And our new side between the two red boxes right here would be represented by x minus a, because the whole side we're going to say is x. So if you cut 4 off on one side and 4 off on the other, you've got a total of a. Volume of this type of figure is the area of the base times the height, would be what you basically are going to do. The base here is a square, so to find the area of the square, it is simply a side squared. So we would take the x minus 8 and square it. The height is 4. When you square this, you could write it in a little bit different form. 4 times x minus 8 squared should equal that 484. Then if you divide both sides by 4, it'll make it a little easier to solve it, because 4 goes into 484 nicely. 4 goes into 484 121 times. So now we have the x minus 8 squared equals 121. You've got a quantity squared on the left, so take the square root to remove that 2, and you're left with x minus 8. When you take the square root of the 121, remember to allow for the plus and minus, so you get plus and minus 11. Separate into your two equations. X minus 8 equals 11. X minus 8 equals negative 11. When we add 8, we get 19. And when we add 8 here, we get negative 3. Well, 19 is okay. We can use that side as being 19, so to speak. But can we use the x equals negative 3? Can we use that? No. Have you ever seen the side of a box that was a negative dimension? No, you can't. This is what we call an extraneous root. It's not applicable to our particular word problem. So the only correct answer here is 19.